Okay, great. All right. Welcome, YouTube Nation. So this video especially goes out to Dane and Willie and Marty and Kendra and Luke. Am I missing anybody? Oh, Mallory. All right. Hopefully you guys check out this video. Should we put something in there to encourage them to watch a video? Like the first person to watch a video and come back and say, the Iowa Hawkeyes are horrible. If you say the Iowa Hawkeyes are horrible, you can have an oatmeal cream pie. There you go. All right. Fair enough? Yeah. Who do you think will get it, Dane? Andrew will watch it first? Okay, maybe Andrew will. Who knows? We'll see. Okay, just two problems today. A man is walking away from a lamppost with a light source 6 meters above the ground, and the man is 2 meters tall. How far from the lamppost is the man when his shadow is 5 meters? I went to meters. I don't want to try to do changing of rates and lengths and stuff like that. Yeah, good question. So I'm going to draw a picture, and if you make fun of my drawing, I'll make fun of you. That's how I retaliate. So just fair warning. What's that, Sam? You got a problem with my drawing? Okay. Logan, you hate my drawing? Just say it, buddy. Own up to it. Okay, so lamppost 6 meters. The dude is 2 meters tall. He's got a really long neck. And it says that his shadow is no torso. The length of the shadow is 5 meters in length. And the question is, what is his distance from the lamp pole? Any thoughts? What do we do? How? How? Pythagorean theorem? Okay, very good. Okay, so Asher, you're absolutely right. We can solve for the hypotenuse here. Unfortunately, it doesn't help us. It doesn't help us. Yeah. Okay, you're getting on to something there that kind of works out. You're 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 suggesting we set up a sort of proportion. So you're saying that the height of the lamppost and the height of the man is going to be proportional to the length of the shadow and this distance overall. Well, how do we know that those are proportional? How many triangles do we have? We have 2 triangles. What tells you that these 2 triangles are proportional? Do you remember your similarity theorems from geometry? What is required? Okay, there was no hesitation there. No, I don't remember, Mr. Gens. Definitely, absolutely not. Well, let's help you remember them, okay? Because this is important. This is a similarity piece that we should all try to bring back to the front of our brains. First of all, we have a 90-degree angle. They share those in common, right? Can you see another angle they share in common? Yeah. That's a shared angle, is it not? Well, if 2 angles are the same, then third angle is the same, right? So angle, angle, angle. If all the angles of a shape are the same, then the shapes must be, or the shapes are similar, and the sides are proportional. So by that theorem, we can then set up a proportion. And I'm going to set up the height divided by the length. So I always like to use 2 labels to kind of organize my work. I have the height of the lamppost, or the height of the man, we'll say, is 2. And the length of the shadow is 5. And I'm going to set that equal to the height of the lamppost is 6. What is the length? D plus 5. Now we can cross multiply and solve. 2 times D is 2D. 2 times 5 is 10, is equal to 30. We subtract the 10. 2D is equal to 20. So D is equal to 10. 10 what? 10 meters. The question is, how far is he from the lamppost? Does D equals 10 meters tell me how far he is from the lamppost? It does. Okay, so we're good. Good job. All right, we're going to try one more. All right, we're going to try another one. This one is a little bit more challenging. When you work through it, you're definitely going to be confused for a little while. Rope. So, but we will work through the confusion. You need to figure this out, okay? You cannot say, oh, I wonder if I'm going to have to use that again. You're going to have to replicate this problem, okay? So it says 2 flagpoles. They have heights of 9 and 13. Hi, Katie. So we have 9 and we have 13. And if you attach a rope to the top of the flagpole and draw it down to the other side, the question is, how far above the ground do the ropes cross? Now, you would never actually want to solve a problem like that, would you? I mean, it's not as though you would walk across in a park, see a couple flagpoles, say, hey, I wonder how far above the ground those ropes are, and take the time to do it. I mean, really, honestly, what's the need? But it requires a method of solving that is very, very, very useful. In fact, I used it this summer when I was building my shed. Okay? You can use it all the time. Now, do you remember how to use it? I don't know. Obviously, I teach math, so I remember those kind of pieces, but it's really quite good. You could try to solve this using similar triangles. The method is quite complex, though, and I think that you would be upset with me if I did it. I'm going to show you what I believe is the easier way and the more efficient way, and it is a new way. I'm going to look at these two things, and I'm going to say that they are lines. And if I want to find this point, I'm looking for what? The intersection of the two lines. And you may say, well, Mr. Gantz, I don't see a slope or a y-intercept or anything like that. Okay. Well, how about now? I'll just slap on a coordinate plane. This is a great way now to solve it. I have two lines. I have one in green and I have one in blue. Can somebody tell me, as I try to write an equation for this first line, the line in green, what would the y-intercept of this green line be? 9. Everybody agree it would cross up here at 9? Okay, so I have y equals something times x plus 9. Now, I have to determine the slope. The slope is the rise over the run. What is the rise to get from this point to this point? -9. I drop 9. Does it say how far we run? It doesn't. So I'm going to create another variable and call it d. So we drop 9, we run d. So -9 over d times x. Is there any question before I move on how I came up with either of those parts? Okay, let's look at the blue line. What's the y-intercept of the blue line? 0. That makes it quite nice, doesn't it? All right, if the y-intercept is 0, what is the rise to get from this point to this point? 13, what's the run? D. So y is equal to 13 over d times x. Now, I know that you don't like d. Don't worry about it, okay? Just let it be, and we'll get to it in a little bit. I want to find the intersection point. I have two lines. Do you remember the two methods you have for finding intersection of lines? One starts with S, one starts with E. One rhymes with substitution. Substitution. Good. So substitution is 1. Do you know what the other one is? Elimination. Good job. So I'm going to use substitution in this option. And I'm going to circle what y is equal to, and I'm going to plug it in for y right there. What's that? We good? All right. So I'm going to plug it in right there, and I've got 13 over d times x is equal to negative 9 over d times x plus 9. Understand that as I'm finding this coordinate, I'm looking for an x, y value. Tell me, am I currently solving for the x value or the y value? I'm solving for the x. You can see the x's are right here. I'm going to gather the x's on one side. I'm going to add 9 over d to both 9 over dx, excuse me. And I get 22 over d times x is equal to 9. What would you do to both sides to solve for x? Times it by d over 22. And you get x is equal to 9 times d divided by 22. Awesome. We have one of the values of our coordinate. We have the x value is 9d divided by 22. Now, I know you don't like that because it has a variable in it, but look at the coordinate. If we want to know the height at which it crosses, is that going to be the x value or the y value if we want to know the height? The y value. Well, I have the x value. I don't have the y value. So if I have the x value, what do I do with the x value to find the y value? Plug it in. So y is equal to 13 over d times, what is x? 9d over 22. What do you notice happens? The d's cancel, just like you wanted to. You wanted those d values to go away, and they do. And I get 9 times 13 divided by 22, which is 5.32. So what did we learn? We learned that the height at which they cross is 5.32. Furthermore, we learned that it doesn't matter how far apart they are. If we were to stretch these 100 feet apart, the height would still be the same. If we push them, 1 foot apart, the height would still be the same. The length at which they intersect would be different, but the height would be the same. So a very interesting problem, a nice problem. Some people say it's way too complex for kids to be able to do. I disagree. Every year I've taught it, people are like, ooh, that looks challenging. Well, try it on your worksheet. Then try it on your study guide. And trust me, you'll get it. You're fully capable. And this option, totally useful. I'll come around and show you a picture of my shed, and I'll show you how I use this when I built it. We're done for the day. What you're going to do is now you're capable of finishing the problems 1 through 11 on the front. So I was walking around today. Some people were at about problem 6 from yesterday, whatever it might be. You're capable of doing 1 through 11. Should you do it on this, or should you do it on a separate sheet of paper? Separate sheet of paper. You have the rest of the time to work. We are out of here at 1 o'clock, which gives you 25 minutes. Not too bad, okay? And the answer key is online. So anyway, thanks for listening, and hope you guys understand what you're doing. Otherwise, I guess you can rewatch it.